I must be a member of House Baratheon because Z8 Fury, ours is the Fury. I guess, well, Game of Thrones is no longer in vogue, but this is an HP workstation, truly a workstation. It could give me a run for my money on terms of DIY builds, because usually I'm all about DIY builds, but economically things are weird. Sometimes you can get a pre-built for less than what you can actually build one for through your corporate purchasing manager, not directly off the website. Never buy actually directly off the website. This is a Xeon 678X, 48 cores. Got 2 GPUs in here, 2 RTX 6000s. But the Z8 Fury G6i workstation from HP is kind of the start of the show and what I want to talk about. So first up, this workstation is on loan from HP, but this is not a sponsored review. They haven't paid me. There's been no money. I'm borrowing this machine because, well, it's got 10 expansion slots. The whole reason this generation Xeon 6 and also Threadripper DDR5 memory runs hot. And the design, I think, of DIY workstations is getting ready to change. And the internals, is superior to what you can do with a DIY build. And I think this is something we need to lean into for the next generation or maybe the generation after that. If you look internally, there's 2 groups of PCIe slots on either side of the processor, and the memory is located in front of and behind the CPU socket. This is a better design. This is a much better design, especially if you were going to pack 4 GPUs in here, which HP actually does support. Now in this configuration, I've got 2, one in the top, one in the bottom. This is an optimal cooling solution. This is an optimal cooling situation. The memory situation, the memory cooling situation usually is front to back. The DIMMs are usually oriented front to back for cooling. But if you're going to orient the PCIe slots this way, then the DIMM slots have to be oriented that way. But that's okay because HP has added fans. This is a dual channel design, so you can rock 2 terabytes of memory here if you could possibly afford that. But that's what Intel is also leaning into with their platform. The best feature of Xeon 6 in workstations is their memory bandwidth and their memory support. It's second to none. It's the fastest thing about the 658X. And don't worry, we'll have comparative benchmarks in just a little bit. Another big improvement is the modular power supplies. Now, this is not my first rodeo with modular HP workstations. I actually have kind of a lot of experience dealing with the older, I think it was G4, G5. I was really not a fan of how they did the modular design there and the power supplies. This is very much improved. The power supply situation here, you've got some options all the way up to 2 kilowatts, 110 all the way up to 240 volts, auto sensing. The power supplies can work in tandem mode, which means that they each supply power to the machine, which means you could run this off of 2 North American breakers because that's where we are with workstations these days. They need upwards of 1600 watts. You could also run them in active standby. In this configuration, it's no problem. I've only got 600 watts of GPU total, plus our CPU socket, 350 to 500 watts, give or take, plus all the other accoutrement in the system. This thing is not going to draw more than 1500 watts, even if I had a 4 GPU configuration running till, like full flat out. Now, for most workloads, those 300 watt GPUs aren't even using 300 watts, especially if we're talking about inferencing or anything else. So this is a pretty smart power supply design. The other thing is if you look carefully at the back, there's 10 expansion slots. There's 10 physical slots. Now, one of the slots, this one here at the top, is 1 slot with 1 blank. So there's not actually physically 10 slots. There's like 9-ish, and the lanes are split up pretty intelligently. There are also PCIe lanes that are rounded to MCIO headers. PCIe lanes could be spent on storage, they could be spent on PCIe peripherals, they could be spent on other things that are kind of like PCIe peripherals, like M.2, somewhere else in the system, other headers. What I'm trying to get at is that at the back here, there's also a modular slot. Now this is HP proprietary, but the interface is MCIO, so you could break that out with a cable or something else if you want to go off script. But what HP provides is up to a 25 gigabit network add-in card internally there that doesn't consume a PCIe slot. But with 10 slots, the thing that you could run here, like the thing that's amazing, is if you had 4 2-slot GPUs, you still have 2 accessible slots that you could put other peripherals in, like a 200 gigabit networking or an FPGA or other PCIe storage. You can't do that on a DIY system unless you get really creative with breakout cables and extensions and things that will introduce unreliability. Internally, you also got other options like 2 3.5-inch bays and the wiring and that sort of thing for that. So if you're going to use mechanical storage, that's no problem. HP has other options for more PCIe storage. You know, you can do E1, E3 storage. It depends on the model and it depends on some other things. But the full range of storage options is here because you get the MCIO headers that can go to whatever you want. This configuration came equipped with 4 M.2. I've got 1 high-performance PCIe Gen 5 Phison M.2, and then I have 3 high write-endurance SanDisk M.2 for our data, our data storage, data workload, however you want to think about that. That's pretty awesome because you can run up to 8 M.2 on board, in addition to all the other storage options. I'm definitely a fan of modularity. Now for the front I/O, HP offers a couple different options. You've got card reader options, USB-C, USB-C power delivery, USB Type-A. There's also an optical drive if you'd like a slim optical drive because you're still living in the 90s. Definitely an option. Now I really like that HP has more or less embraced the relatively standard MCIO connector for their PCIe interface. There are other aspects of the system that are, proprietary. Like you're going to need HP expansion modules if you're going to do this, that, or the other, but still having 10 expansion slots gives you a lot of options for the PCIe end of things as well. This platform gives you 16 lanes of Gen 5 connectivity to all 4 of the slots they intend for you to use for GPUs, and they can make a difference in multi-GPU configuration. Now, for workstations and workstation benchmarking, let's start there before we get into the AI stuff, because Xeon 6 is kind of an interesting thing. Look at Procyon. Procyon is relatively standard, from UL benchmark for computer vision, and it really shows how much of an improvement Intel has made over their previous generation. Our 678X 48 cores here, it performs really shockingly well against past generation Xeon workstation CPUs. Intel's in the game, they're in the running. The CPU focus and the CPU aspect of the Procyon benchmarks show just how much Intel has improved over the last generation. It is really breathtaking. And I have to step to a larger picture of not just Procyon, but also other CPU-based benchmarks. We've got the full Phoronix test suite results there as well. Macroscopically, what's going on here is Intel has AMX, and they have accelerators, and they have on-silicon stuff, and their memory subsystem and memory controller is very, very good. It is shockingly good this generation, especially over last generation. 2 DIMMs per slot, 2 terabyte memory capacity, you can really lean into that. Our test configuration here was 128 gigabytes. Against Threadripper competition, generally, especially at lower core counts, Intel will pull ahead in terms of memory latency and overall memory bandwidth. And it's really just because of the structure of their memory controller is a little different. But you can make that up on Threadripper with more core count. So like 48 cores versus 64 cores on Threadripper, this is going to be a little, it's going to be slower. And it's not just because of the core counts, it's because more cores is able to better keep up with the available memory bandwidth on the platform. Whereas Intel, even in my own testing, all the way down to 24 cores, the 24 core configuration, the amount of memory bandwidth that is available in a relatively limited 24 core configuration is pretty good on the Intel platform. It depends a little bit on the workload too. It depends on the access pattern because there's stuff in the CPU that's like, oh, this is a pattern of access. Let me just preemptively load this stuff from memory. And AMD is quite good at doing that as well. So as you look at the benchmarks and you dive into the details, in general, Zen 5 cores have more compute per core, but the overall platform from Intel here is at least as good, at least at parity, if not a little bit better, especially at lower core counts with memory access. Now, if you go top to top, if you do the top end SKU from Intel Xeon versus a 96 core Threadripper Pro, you've got 96 cores. It's going to keep the memory, it's going to be able to access all of the memory. The bottleneck is not going to be you don't have enough cores to access the memory anymore. So it's interesting how that takes shape as we look at the different benchmarks. Now for the HP test, it ships with Windows. I'm doing a lot of tests with Windows. Thank goodness for 3D Mark. 3D Mark and their Procyon suite gives you an idea of the kind of performance that you can get on Windows. And the full breakdown of that is on the forum with a lot more detail than I can get into here. A lot more detail, a lot more numbers, a lot of number crunching, a lot of stuff that's going to make it easy to compare both the CPU and the CPU platform, like the Workstation platform, as well as those Max-Q RTX 6000 GPUs. Needless to say, it's a very impressive setup, especially when you consider how far the software has come even over the last 90 days. When I started with this system to now, which is the beginning of August 2026, it's fully 20% faster with a whole bunch of updates that have landed for Blackwell. Now, most people don't realize that the Blackwell that's in the RTX Pro 6000 is different than the Blackwell that's in GB300. And one of the big breakthroughs recently, just in the last couple of weeks, was I think it's a fused multiply type operation that has been unlocked in the SM120 because it works a little differently in the SM120. And in order to take advantage of that, I have to run Linux. And so the full Linux benchmarks are also in this thread. There's so much here. There's so much to unpack. Just to take one model as an example, DeepSeek V4 Flash 0731 came out just a couple of days ago, and if you look at it and you look at its model card on Hugging Face, it is almost as good as Opus 4.8. And then the other aspect of this for Workstation and Workstation testing outside the canned benchmarks and outside Workstation benchmarks is, of course, AI. And Intel with AMX gives you some options for doing stuff on the CPU. But the CPU can also make a difference even with things like VLLM, doing scheduling and everything else like that, across the GPUs, because VLLM depends on CPU stuff, CPU scheduling, in order to decide which GPUs are doing what. And that can also show up in the benchmarks when we're talking about smaller models and very high concurrency. And so that's very interesting as we look at the benchmarks and the different performance as we go from smaller models to larger models. With larger models, it really doesn't make that much of a difference. Like the CPU is no longer the bottleneck there. So sort of fun. And so understand that I just picked the model, but I'm trying to pick some real world workloads for on the AI side of things to show you alongside of the Workstation workloads so that you get an idea of the performance and the sort of fun things that you can do. If you don't take anything else away from these numbers and the performance here, look closely at your token cost in the cloud. If it's $10 to $25 per million tokens of output, you might be shocked at how quick a system like this can pay for itself. And if that token price is only going up from here, I don't know, it might be worth a look. Now, it's also been an evolving story over the last couple of weeks, specifically with the DeepSeek V4 Flash. This workstation has become an ideal platform for running DeepSeek V4 Flash and models like that, not necessarily that specific model, but models like that locally. It's challenging to run DeepSeek V4 Flash with the full 1 million token context at high concurrency with just 2 RTX Pro 6000s, but 4 can get it done. And we're talking 600 tokens per second. But it didn't start out at 600 tokens per second. It started out at around 100 tokens per second. But there has been software breakthrough after software breakthrough after software breakthrough. We're almost to the point where frontier models and really expensive cloud systems like multi-million dollar to $100 million cloud systems are almost, but not quite to the point where it's recursive self-improvement, where you can sit down with AI agents and a model and say, hey, I've got this physical hardware. How do we get to where we can run this model that'll fit in VRAM efficiently and really effectively? And we're not quite there yet, but that is why it seems like the tooling, like better tooling, better interfacing, is why there's this apparent acceleration. Because going from 100 tokens per second on a model like DeepSeek V4 Flash to 600 tokens per second on this hardware is a breathtaking improvement. And that model is large enough and competent enough that it is useful to teams working locally or working on sensitive information. And the fact that this is a PCIe system means that you're going to be able to swap in next generation or next generation hardware, assuming that we have availability. So the bottom line, if you've worked on the HP workstations previously, like previous generation workstations like G4, G5, serviceability, especially around the power supply and some of the other components, not great. It's super great here. Fantastic. No complaints there. So toollessness is improved. The toollessness, even for the top GPU, HP's put a lot of thought into the chassis and serviceability and making it easy to work on. At the same time, we haven't really sacrificed any performance. If I had really any complaints, it is like when you buy a system like this, the motherboard marries the CPU. So if I were to take this CPU out and try to use it in a standard motherboard, it's not going to work. The CPU is literally married to HP. If I go to a retailer and I buy a retail Xeon Workstation CPU and put it in the system, it will become married to this system. So when you get a retail CPU, it'll work in whatever. But as soon as I put it in this system, the system blows a fuse, basically, or blows a series of fuses. It's a cryptographic thing in the CPU, and then the CPU becomes married to this platform. And that's true whether it's AMD, that's true whether it's Intel. I don't really like that kind of behavior in the platform overall. It's supply chain. It's like, oh, supply chain integrity. It's like, is it though? I mean, for the CPU, okay. Fortunately, it's not like that with RAM or anything else like that. If you can get your hands on SK Hynix or Samsung or standard JEDEC memory, that will work fine in here within the parameters of specifications, generally. Although if it doesn't work, and you're going to be on your own for support. So I'm thinking Workstation's upgradability, 5-year timescale. If you're buying a system like this, 5-year timescale. As configured on the website, it is some ludicrous amount of money, like $50,000. But the reality is that if you are in corporate or purchasing, you have a purchasing agent that you go through that gets you better pricing. Nobody ever pays the website pricing. Like, you should go through a purchasing agent and figure that out. And that is true of all of the big names in workstations. But because things have been so crazy in the market, sometimes through resellers and sometimes through advertising, you can find fully put together workstations like this with high-end parts that cost less than the equivalent amount of parts that you can buy today. And that's because this system was put together and paid for some time ago, and it sat on a shelf for a month or 2 or 3, although it's not true directly from HP, true maybe from some resellers and some other ones. And so sometimes you can get into a situation where you can acquire a system like this for a scary, crazy good deal. And there's not really a downside. And I think we could actually learn some things in the DIY market in terms of internal layout. Like, the internal layout here is fantastic for cooling, it is fantastic for reliability, it's fantastic for serviceability, and you don't really sacrifice anything in terms of performance or anything else. Yes, the motherboard can't be replaced by anything except another equivalent HP motherboard, and HP parts, HP service, like, you'll have to go through that at some point in the future, but this is actually good news for corporations and corporate fleets. I mean, if you're in purchasing, weigh in the comments, because I know that there are those among you like me. It's like, no, I want to build my own workstation, and it's like, that's more like a pet. If I need a herd of cattle across my enterprise, this is more like cattle, and that's a good thing. And the performance here really doesn't leave anything to be desired. Intel Xeon 6 is the best Xeon that Intel has had in years. Zen 5 does beat Xeon 6 in several scenarios, but in key workstation scenarios, Xeon 6 does pretty well too. And Xeon 6 is pretty well ahead of Zen 4 for pretty much everything. So I land somewhere between Zen 4 and Zen 5. 48 cores, 32 cores, but if you need AMX, you want to run OpenVINO, VLLM optimizations for the Intel side of things for scheduling and everything else, it's all there. Like, all the pieces are there. There's not really a downside for Xeon 6. I'm sure everybody wanted Xeon 6 to be, head and shoulders better than Zen 5 in every category. But this is really good, and you shouldn't hyper-focus on the benchmarks, because the memory bandwidth, especially at lower core counts, is really good, and it's got the chops for all of the other non-AI workstation benchmarks as well, which is nice to see. It's nice to have a competitive platform here, because I don't know what else is going to keep pricing in check. Now, just in the last few days, one of the most exciting things about local development and local models has happened. What if I told you that this machine, as it's configured with its 2 GPUs, can run a state-of-the-art model in a million context window that gives Opus 4.8 a run for its money? Yeah, you can do that on this machine. Opus 4.8, if you're not clued in right now at the time that I'm doing this video, is about $25 per million tokens, or $12.50 per million tokens if you're running it in batch processing mode, which is, the quality of service is lower. That means that this machine has a payback time on the order of a month. yeah, because the cost of tokens are so out of whack. How? It's DeepSeek 0731. And if you take a look at the model page and the benchmarks, it has coding benchmarks and reasoning benchmarks and a lot of other things. And the format and the fact that, there's some cool stuff in the Blackwell architecture for 4-bit. You can run the native version, you can run DSpark. There's a full tutorial on the level 1 text form that will get you up and running at speed. You can get on the order of 1,500 tokens per second from this setup. There's a couple caveats there, but I feel like you can do at least 1,000 tokens per second in the worst case scenario with the most state-of-the-art software. And some of that is not just the model, because some of you are like, oh, I don't want to run that model, I need some other model for whatever reason. That's fine. But the software engineering that has gone into being able to run those kind of models at speed and to provide a context of 1.5 million tokens for any number of sessions that you would run in that shared pool of 1.5 million tokens of context. The model itself is up to 1 million tokens per stream, but you could run 2 streams with a combined total of 1.5 million, or a bunch of agents with 256K. The software engineering to be able to do that in this relatively small amount of VRAM is incredible. It is astonishing. This is a better state-of-the-art model than state-of-the-art models just a few months ago with a higher parameter count. So this model is smaller, faster, smarter, denser. And that's coming across a whole bunch of other models. Inkling here in the US, it's looking like a really well-engineered, solid model. It's a startup that just came out of stealth mode. It's a little too big to use with just 2 GPUs. You could probably do it with 4, but the model isn't just the interesting thing. It's the software engineering to make it all run absurdly fast, and the full benchmarks and comparisons and my own stuff. Because sometimes you get into benchmaxing, like Meta got themselves into a little bit of trouble with their model being benchmaxed, which means that it will benchmark really well, but then when you actually go to use it, it doesn't work quite as well as advertised. That has not been my experience with this particular model, because I have kicked the crap out of it in order to do this, that, and the other. So check out the how-tos and the guides that I've done with this workstation and this model, and I think you'll be surprised, because I was surprised. I think we might be in for a cost correction in terms of cloud token costs, or perhaps even worse, a cost correction in terms of hardware costs. Gosh, I hope not, because the costs are already. I will list level 1. This has been a quick look at the HP workstation, the Z8 G6i. If you have any questions or I missed anything, you want to see some more workloads run on it, let me know. I'm signing out, and you can find me in the forums.